calculation of elasticity of substitution. So we'll look at three kinds of production function: Cobb-Douglas, perfect complements, and perfect substitutes. And we'll try to find out the elasticity of substitution for each of them. So let us start with this Cobb-Douglas. Production function. So you have Q is equal to f of KL is, let's say, AK to the power alpha, L to the power beta. Right. So how do you find out, okay, what is the elasticity of substitution? Percentage change in K by L upon percentage change in K by L upon percentage change in MRTS, right? Which you have written as d log of K by L upon d log of MRTS, right? So let me just find out MRTS first. MRTS is del Q by del L MPL upon del Q by del K. That is what MRTS is. So del Q by del L for this production function is what? A beta L to the power beta minus 1 K to the power alpha. That is what MPL is. Del Q by del K is what? A alpha K to the power alpha minus 1 L to the power beta. So this A will get cancelled out. You will have what? Beta by alpha, right? And this you can write as alpha minus, I mean, you just take this alpha minus 1 up, this minus alpha plus 1 whole upon L to the power beta. This thing coming down is minus of beta minus 1. This is minus of beta plus 1. So what you have is beta by alpha K by L. That is what MRTS is. What is DMRTS then? Okay, let me just take the log first. So log of MRTS is what? Log of beta by alpha plus log of K by L, right? What is d log of MRTS? Is d log of beta by alpha plus d log of K by L, right? Now what I can do is I can divide, okay, one more thing is that this is a constant. So the derivative of a constant is 0. What you can think of is that you can divide both the sides by d log of MRTS. So what will that be then? So what is this? This is your sigma. Elasticity of substitution, d log of K by L upon d log of MRTS. So this is equal to 1. This is equal to 1. Right? Okay, so this was your first case, Cobb-Douglas. Let us look at the another case. Let's look at the another case, which is your perfect complements. Fixed proportions production function. fixed proportions production function, right? So you have a function like, let's say, q is equal to min of akbl. A and b are both greater than 0. So this is what the production function looks like, right? Now there are few cases. Suppose ak is less than bl, then capital is a binding constraint. So if you keep on just increasing labor, your output is not going to increase, right? So output will remain constant then. So MPL is 0 at this stretch when AK is less than BL. You keep unnecessarily increasing labor, that is not going to help at all. So when AK is less than BL, then in that case Q is equal to AK. Whatever is minimum, you will pick that out from here. So we would say that capital is a binding constraint. Capital is a binding constraint, right, in the production process. So if you employ more labor, but you just have this much of capital, if you keep on just employing extra labor, that is not useful. So that additional labor is not adding any value to the output. So the employment of labor the employment of more labor would not increase the output. So MPL is equal to 0, right? So MPL is equal to 0. Hmm? Second, at that stretch, but guys, you know this, right? I mean, you know that the min production function will look like this. Uh, will look like this. So we are talking about this stretch. Here MPL is equal to 0, right? That is, if you keep on increasing your labor without an increase in capital, it is not going to help at all. Uh, Now suppose AK is greater than BL. So if AK is greater than BL, then labor is a binding constraint. Your Q is equal to what? B by L. Labor is a binding constraint. Uh, so you unnecessarily increase capital, it is not going to help. So the additional capital is superfluous. Additional capital is superfluous, right? That is one thing. Other, when AK is equal to BL, then both inputs are fully employed, right? Then both inputs are fully employed. You're not using any input unnecessarily. Both inputs are fully employed. So when this happens, That is when AK is equal to BL. So you guys can write K by L equals to B by A, right? So, and the production is going to take place at this particular point. That is at the vertex of an isoquant. And the production takes place at a vertex on the isoquant map, right, beta? Um, so you mean this. You mean this. You have labor, you have capital, and the kink line is this guy, right? AK equals to BL. AK equals to BL, right? That is, uh, and the production is going to happen here at the vertex. Production is going to happen here at the vertex. Beta G. So if AK is equal to BL, so you guys, I mean, this is true, na? This is true. So I can write K as what? Q by A. L as what? Q by P. I can write like this, na? So you have what? Tuck, 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 tuck. So K is what? Q by A. L is what? Q by P. So you'll be producing at this particular point. You'll be producing at this particular point. So, and the locus of all such vertices is a straight line from the origin, right, which has a slope of B by A. So you can just write that point as well. The locus of all such vertices, this kink line I'm saying, of all such vertices is a straight line through origin is a straight line through origin with a slope given by B by A. So when you have this kind of the production function, then the production process has to use the inputs only in the fixed ratio. That's true, right? So for this kind of the production function, right? So capital in labor must be used in a fixed ratio for this production function. Must be used in a fixed ratio. So a firm which is characterized by this production function will always be operating at a vertex of the isoquant map, right? Will always be operating along a ray from the origin at which k by l ratio is constant. So along this ray from the origin, so if you look at what your k by l ratio is, that is b by a. So this K by L ratio is constant. Mhm. This ratio is constant along this ray from origin. That's true. And you will, I mean, if you have the production function like this, then you will be only operating at these vertices only. So a higher isoquant would be like this. Uh, so you might use more amount of capital and more amount of labor here, but the ratio is same B by A. But the ratio is same B by A, right? So to operate, and if you operate, okay, fine. For example, if you operate here, you are unnecessarily using more labor, because this labor, although you have the same amount of capital, but you have more amount of labor, that is still producing just Q naught. That is still producing just Q naught, right? If you're using more capital and this much amount of labor, you're still producing Q naught only. So that is inefficient. So if you produce at any point other than the vertex, that is inefficient completely. To operate at some point other than the vertex, right, of the isoquants. But all of this is true only for this production function, right? Will be inefficient, right? Because you can produce, for example, if you want to produce Q naught, why on this earth you will use this much amount of capital and an unnecessarily more amount of labor? If you move or contract towards the vertex, you're producing the same level of output, because even here, by using more amount of labor with this much amount of capital, you are still producing Q naught. So that is efficient, that if you use less amount of labor, right? Because the same output can be produced, right, with fewer inputs by moving towards a vertex. By moving towards a vertex. Acha. Having said that, now where is elasticity of substitution coming? What is elasticity of substitution? D log of K by L upon D log of MRTS. This is what elasticity of substitution is. What is D log of K by L here? Beta, K by L is same na. I mean, that is a constant thing. That's a constant thing. So there is no change in K by L ratio, that is fixed. This is 0. So numerator is 0, that's gone. So K by L is constant. This K by L ratio for a fixed inputs production function, K by L ratio is constant. So the numerator for elasticity of substitution is constant. Hence sigma is 0. Hence sigma is 0. Third, linear production function. Linear production function. A linear production function. So suppose you have Q is equal to AK plus BL, right? Now these isoquants the what do you call slope which is same, right? These are downward sloping straight lines and their slopes are same. That is their slope is constant. I mean, I should rather say. So if you just want to find out the MRTS in this case, del Q by del L upon del Q by del K. Del Q by del L is B, del Q by del K is A, right? So all isoquants of such kind, linear production, I mean, linear production function, that is basically your capital and labor are perfectly substitutable. I mean, you don't see such things in real life, but supposedly if it is. So all isoquants of this production function are parallel straight lines. Are parallel straight lines with a slope minus b by, right? So the slopes are same, right? So it's not like a Cobb-Douglas function. For example, you have a Cobb-Douglas function. The slope is changing at every point, right? Here the slope is same. Hmm? So you have labor, you have capital, and if you say Q is equal to AK plus BL, and if you are not using labor at all, if you're not using labor at all, so I should rather write like this. So if K is 0, L is Q by B. If L is 0, K is Q by A. Q by B. So what is the slope for this beta? This you know from your micro course. Q by A upon Q by B. Right? So this will come out to be B by A. That is the slope. So slope is same. Slope is same. Okay. So MRTS is constant along any straight line. Along any straight line isoquant. Right. So what is the definition for sigma? dk by L upon dmRTS. But a k by L might change from this point to this point. Let's say you're sitting at A, you're sitting at B. So you're using maybe more capital, less labor here. You're using more labor, less capital here. So K by L might change, but MRTS is same. So this is 0. And if this is 0, then if denominator of sigma is 0, then this is going to be infinity. Right? This is going to be infinity. Hence for a linear production function, your sigma is infinity. Huh? So this is what we were talking about, I think the other day when we talked about this guy. We said na, if MRTS doesn't change at all, for changes in K by L, substitution is easy. If MRTS changes rapidly, for small changes in K by L, substitution is difficult. Your high sigma, low sigma, uh, that is, these are the same thing. So high sigma is your MRTS will not change much relative to the changes in K by L. That is what your perfect substitutes. Low sigma, uh, MRTS will change by the substantial amount as K by L is going to change. That is perfect complements kind of production function. Right, beta? So this is what I wanted to do in this class. Thank you.